Now let's begin the application of derivatives. First, tangents and normals. So the derivative of a function at a point is the slope of the tangent line at this point. Let's say here x0 is a given point, right, on the function of f of x. So when you draw a tangent line on this point, the derivative of the function gives you the slope of this tangent line, okay, which is also equal to tangent alpha. So this is the first rule you have to know. For example, here fx is equal to x squared over 4 plus 1. So what is the slope? So as you can see here, x0 is given as 2. So we will take the derivative of this function and then we will put 2 instead of x. So let's do that. The derivative of f of x is equal to 2x over 4, which is equal to x over 2. So let's put 2 instead of x. It will be equal to 2 times 2, it's 4, 4 over 4. So this is equal to 1. This is also the slope of the tangent. Also, I can write this as this mt. This is equal to 1. In this example, we have what is the slope of a tangent line of f of x is equal to sine 2x plus 1 at x is equal to p over 6. So we will do the same thing. We will take the derivative of f of x and then we will put p over 6 instead of x. So let's do that. The derivative of f of x is equal to, so the derivative of sine, it is cosine, right? It's cosine 2x, and we also need to take the derivative of this 2x, which is equal to 2. So since 1 is a constant, we don't need to take its derivative because it is equal to 0. So now I can put this value instead of x. So let's do that. Derivative of p over 6, which is equal to 2 times cosine 2x. So it is 2p over 6, which is equal to p over 3, and this is all equal to 2 times, so this is 180 over 3, it is 60, so cosine 60, it's equal to 1 over 2. So when we simplify these two, we will get our answer as 1. Let's continue with the normal line. So the normal line is defined as the line that is perpendicular to the tangent line at the point of tangency. You see here on this point, it's perpendicular to tangent line. So because they are perpendicular to each other, they are negative reciprocals of one another, and the slope of the normal line to the graph of this f of x is equal to 1 over the derivative of f of x, and it also has the minus sign. Why? Because these lines, they are perpendicular to each other, and I can call this as the slope of normal line. So we can say that the slope of tangent line times the slope of normal line is equal to minus 1, because I know that the slope of tangent line, this is equal to the derivative of f of x, right? So when you multiply this by the slope of normal line, this is minus 1 over derivative of f of x. So from here, as you can see, we will get minus 1. Let's look at this example. Here we have what is the slope of a normal line of f of x is equal to x squared plus 3x plus 1 at x is equal to 1. So let's first find the slope of the tangent line, and after that it will be easier for us to find the slope of the normal line. So let's do that. How we find the slope of tangent line? We will take the first derivative of this f of x. So the derivative of f of x is equal to, this is 2x plus 3, right? So after that we will put 1 instead of x. So this is the derivative of f of x at x is equal to 1. And here we will have 2 times 1 plus 3, which is equal to 5. So this is the slope of our tangent line, which is equal to mt, okay? So I know that mt times mn is equal to minus 1. So from here, 5 times mn is equal to minus 1, and mn is equal to minus 1 over 5. Now let's see how we write equations for these lines. So we know this slope formula from analytic geometry, right? This is the slope is equal to y minus y0 over x minus x0. So we will use this formula to write our equations for our tangent line and normal line. So to write the tangent line equation, we just do cross multiplication here, okay? But instead of m, of course, we use the slope of our tangent line. And the same thing goes for the normal line. For the normal line, we will do the same thing, but instead of mt, here we will write mn. And as you know, mt, let's say this is equal to m. We know that mn is equal to minus 1 over m. Let's look at this example. Here we have write an equation for the normal line and tangent line to the curve f of x is equal to x to the power of 3 plus 2x at the point x is equal to 3. So first let's find the slopes, and after that it will be easier for us to write the equations. So let's do that. Let's first find the slope of the tangent line. Okay, so it is the derivative of f of x. Okay, so this is equal to 3x squared plus 2, right? Now I can put 3 instead of x, so this 3 is given. So I will put this 3 instead of x. So from here we will get 3 times 3 squared, it's 9, 9 times 3, it's 27, plus 2, this is 29. So this 29 is the slope of our tangent line, okay? So this is equal to mt. So I know that mt times mn is equal to minus 1. So from here it's 29 times mn is equal to minus 1, and from here mn is equal to minus 1 over 29. Okay, now let's write our equations. So it is y minus y0 is equal to m times x minus x0. This formula, this equation, it's the same for the normal line and for the tangent line. Just there's one difference, that is the slope, right? So let's first find the y0 here, because we know x0, right? x0 is equal to 3. So when I put 3 in our equation, I will be able to find the value of y0. So let's do that. So y0 is equal to 3 cubed plus 2 times 3. So this is 27 plus 6. This is equal to 33. Okay, now I can write my equations. Let's do that. So here we have y minus y0, it's 33. Okay, is equal to, let's first write our tangent line. So here for m, we will use this one, right? The slope of tangent line, which is equal to 29 times x minus our x0 is equal to 3. Okay, so from here we will get y, so this is y minus 33 is equal to 29 x minus, this is 29 times 3, this is 3 times 5, 27, it's 87. Okay, so we will leave we will all put all them together, and from here y minus 29x plus 54 is equal to 0. So this is the equation of the tangent line. Okay, this is a tangent line. So let's look at our normal line, same logic. So it is y minus 33, which is equal to, instead of 29, I will write minus 1 over 29 and x minus 3. So this is the equation. This is the equation for our normal line. So this is the process you need to follow to get the right answer in this kind of questions. Let's look at this example. Here we have find the points on the curve f of x is equal to x squared plus 10 at which the tangent line is parallel to the line y plus 8x plus 10 is equal to 0. So let's say this is our curve of f of x, okay, and we have here our tangent line. Oops, sorry, this is our tangent line. Okay, so let's say this is our tangent line. So this line, it says that this line is parallel to our tangent line. So also this line is something like this, okay? So these two lines, our tangent line and this line, they are parallel to each other. If they are parallel to each other, it means that their slope are the same, okay? So how can we find the slope of this line? So this is very simple. We leave y alone, and the coefficient of x is our slope, right? So let's do that. So y plus 8x plus 10 is equal to 0. So here y is equal to, I put this minus x to other side, minus 8x, and this one goes as minus 10. So as you can see here, this minus 8 is actually the slope. So this is empty is equal to minus 8. Why this is empty? Because this line also parallel to our tangent line, which means their slopes, they're equal to each other, and that's why our tangent line's slope is also equal to minus 8. So let's go back to our function here. So we have our function as x squared plus 10, right? So how I find the value of the slope of tangent line? So it is, we take the first derivative, right? So the first derivative of our function is equal to 2x. Okay, so let's say this point, it's on the a. Okay, so it means the derivative of f of a is equal to 2a, which is also equal to minus 8, because this gives us the slope of our tangent line, right? So from here we find a as minus 4. So this is on the x-axis. Okay, so to find y, we take this value and we take this value and put on our function. So let's do that. So y is equal to x squared plus 10. So instead of x, I will put 4. So y is equal to, so minus 4 squared, it is 16. 16 plus 10, this is equal to 26. So the points for this example, the answer for this example is minus 4 and 26. Now let's continue with this example. Here we have this parabola, and this is its tangent line. So here we have y is equal to ax squared plus bx plus c. So what is the value of 4a plus b plus c? So in this on this tangent line, as you can see, we have here 45 degrees, but this is not, it is tangent angle. So its tangent angle is actually, it's here. So this is also equal to 45 degrees, okay? But here, this 45 degrees, it's on the negative direction. That's why this here, the slope is equal to tangent 135 degrees, okay? Why? Because it's on the negative direction. So tangent 135 degrees is equal to minus 1. Okay, so this is the slope of this tangent line. Okay, so let's continue. So we know that the first derivative of f of x, which is here y, is equal to our slope, right? So let's take its derivative. So its derivative is equal to, when I put this 2 in front of ax, it is 2ax plus b, right? Okay, so this value, this slope, this is the tangent line at the point x, when x is equal to 2, right? So that's why we will put 2 instead of x here, and we will equalize this to minus 1. So let's do that. So the derivative of f of 2, which is equal to, when I put 2 instead of x, it's 4a plus b. So 4a plus b is equal to minus 1. As you can see also here in the question, it's asked for a plus b. So we know the value of for a plus b, which is equal to minus 1. So how can we find the value of c? So it's very simple. When we look at this graph, we see that when x is equal to 0, y is equal to 3. So let's put this let's put these values on the equation, on our function. So it will be ax squared plus bx plus c. So here c is equal to 3. Why? Because when you put 0 instead of x, this will be 0, this will be 0. So y is equal to c. Since it's 3, when x is equal to 0, c is equal to 3. So c is equal to 3. So our answer to this example is minus 1 plus 3, which is equal to 2.